specialist and business channel partners and who have delegates coming here and other all my colleagues. Now, morning all our chief guest, keynote speaker and IPTA president all are addressing about the sustainability, innovation and technology. Now, we are going to cover with the what quantum paper, as a quantum paper, what we are doing for the target of 2030 in a short-term target and long-term target of 2070, net zero. Towards moving to net zero decarbonization, what kind of practices we are doing. What we are telling is this is the practical case study which is currently practiced in the mill. Okay, it is not ChatGPT, it is not Microsoft Copilot. It is purely dedicated of case study. Okay, which is happening in the mill. Okay. So, quantum paper is there in the backward integrated area in the Punjab. They started operation in 1980. The 4 decades of the paper industry, last 45 years continuously upgrading their missions capacity with the one-man visionary leadership of Sri Pawan Kaitanji. He is continuously engaged, customer first and people first. These are the slogans we are learning day and night and moving towards the growth of the industry. See, this is the continuous journey from 1980 to 2025. Still we are upgrading the missions according to the market requirement. 1980 we have started 1 and 2 paper machine with 30 ton of capacity. Now today we are producing 550 and still continuously upgradation up to 675 tons per day capacity expansion with backward integration, with forward integration, with sustainable manner. Because of the mill has started with agro, slowly converted into wood also. Because of mix together, we are operating with the quantum paper. Now this is the capacities. We have bulk upgradation and recovery upgradation already happened. It is 700 TPD capacity of recovery and 438 tons of pulp and 675 tons of paper capacity. And we are sustainable, we can say sustainable because of we are ECF bleaching and we have super batch digesters currently coming into the operation. Now we are continuously upgrading our processes through innovations and new technologies by adoption. And apart from that, when we are converted into from agro to wood, then there is a sustainability coming in place. Morning, Sanjay Singh ji bola hai, because of there is a sustainability 50 years back, Mr. Subhi has given an idea that coming in place now today. Because of the sampling capacity started with 4.5 million sampling, now 2027-28 we reach 10 million sampling capacity because of wood sustainability. That is the one thing we are happening. Another plantation point of view, because of the wood, we are not cutting the forest. We are taking the wood from the farmers. For farmer developing program, plantation program, we are covering 16,000 plus acres and shortly we are going to cross by 25,000 acres for the plantation area, near 100 kilometer radius. Now, we are compared to paper industry, energy point of view, global versus India, where we are. 6% of, suppose if we take into the global, amongst 5 industries, top 5 industry, India is the 5th industry which is highly energy intensive. In that 6% industrial energy consumption globally, India is 15 to 18 tons of metric million tons of oil equivalent in 24-25. That is the consumption in the India. Then fossil fuel usage compared to global versus India, there is a lot of difference because of it is completely reverse. If coal consumption, if you see India 50 to 60%, whereas global it is 25 to 30%. The fossil fuel is using coal. Whereas biomass, it is using by India 25 to 30%, whereas global 40-45%. Still, globally, North America, Scandinavia, and India lags behind due to recovery boiler applications. Natural gas, India it is 5 to 7%, 7%, whereas global is 15 to 20%. Then oil 3 to 5% in India, where 5 to 7% in global. These are the just numbers of the where we are India stands against the global. So slowly the India towards moving into the renewable energy, then biomass utilization, then we have to improve the recovery processes to high pressure boilers, then we have to improve the energy conservation activities come into place so that we can slowly carbon footprint, scope 1, scope 2, we can fulfill. Then we have to go to the Paris Agreement in 2030, that is the decarbonization and the climate change. Today we see the climate change. You see what is happening in the Europe. Europe's roads are not meet the temperatures because of the roads are melting. Means the global warming is GHG gas emissions are very crucial for the environment global warming. That's why net zero decarbonization is necessary for the industry where we are responsible for the society. So what the quantum is doing? Quantum we are doing beneath chips waste because of all our total cost of ownership we have to consider. In total cost of ownership, we have to blend with some beneath chips where the raw material availability is near to the area. So beneath chips waste, then beneath chips dust and wood chips and grit straw, these are the raw material we are using in the quantum. These are the raw material and these are processing the beneath chips in the process, in the raw material. It's where dry dust is generated, dust is removed, contamination is removed and fed into the digesters. Because of beneath chips is waste for the plywood industry. Because of we can feed it directly, the digester loadability will be affected. That's why we have to take care before feeding into the digester so that there is a technology in place. So by using the technology, we recover it and using in the boiler as a fuel. Then there is a bark. When we are taking from the farmer the wood, debark is there and bark also there. Then we can internally debarking and making to the debark. Then we are using it to crush it to the powder. Then we have to equal size cut into the boiler as a boiler fuel. Then wood dust during cutting, wood generation, dust generation is there. Then we are using that wood dust also feeding into the boiler. And we are properly storing along with the core. We are mixing proper proportionate of the other biomass materials without affecting the boiler performance. Then coming in, this is the process of beneath chips, how we are screening the material of beneath chips. First we are screening, then wash it, then contaminated and other metals will be removed and the pure material is going into the digester. Because of quality is the prima facie, quality is the customer is the first. So we have to maintain the quality. By doing of this operation, our end product is not getting affected. Because of the end product, beneath chips is having a dust and contamination which is affecting into the final quality. That's why there is a need to remove the contaminants from the initial stage so that you can get the better cooking and better white liquor quality, then better white liquor consumption, reduce the white liquor consumption so that the pulp quality will be maintained. When the pulp quality is maintained, the final product automatically will be achieved in the desired level. So this is the process. The wood dust and there is the aqua separators are there to remove the other contaminants. And wood chips, then wood chipping process. We have an octagonal screen, the dust is removing out and the accepted chips is going to the digester. This is the process for the recovery of wood chips. Then wheat straw also is having a dust and silica, majorly silica. That's we are removing before going into the continuous digester. Then another is paper machine. There is a waste because of sand clearance and process skin rejects are there. There's rejects we are treating and going into the board machine and we are making the board and using and dry it and using into the boiler fuel. This is the whiteboard. Then by using of all the daily waste recovery process distribution, we are almost close to 115 tons per day we are using the biomass. This is except from chemical recovery. It is only purely biomass. Okay, chemical recovery already we are in 38 plus. Apart from that, we are using the biomass and rice husk. Because of why this is needed? Because of we have to control the total cost of operation we need to maintain. That's why alternative fuel has to be developed according to our resources management. We have internal resources management we have taken into consider for the boiler. Okay, you have some questions. Here why you are using all the biomass, who is having the boiler experts also maybe having a question in the mind. Because of why using biomass, how the boiler performance is maintained. Yes, initially we have faced the problem. ऐसा नहीं है, कोई भी नया चीज आता है तो initial problem आता है. How to take it, positive spirit and get the solution. That is the important. Because initially we faced the problem. Then because of all mid-star dust, silica is there, then potassium is there, then all heavy metals are there. That is also a problem. So for that, the depositions has taken place on the ABH tubes. Because of where the velocity is less, there the deposition taken place. Then for that we have introduced into sonic soot blowing so that loose particles should not deposit on the low velocity areas. That is one action we have taken. Apart from that, we are doing annual maintenance by adopting the technology of LFET, low frequency electromagnetic testing. Because of where the wall thickness, superheater thickness and water wall thickness for measurement in every annual shed, we have taken the sleeves. Because of the measurement the thickness, then we have to using the sleeves by providing the sleeves to avoid the damages and stoppage of the missions, stoppage of the boilers. So, by doing of this biomass is having a different biomass is having, because of we are using rejects, we are using the raw material processing dust also. Then there is a problem of moisture and ash. This biomass is having lesser ash than the coal. Fossil fuel say less ash hoga, but moisture there is a variation. Yes, there is a moisture variation is there. What we are doing is, we are mixing with the fuel, then we are maintaining the uniform equilibrium moisture and feeding into the boiler furnace. So, by doing of this, fossil fuel, we are normally, the coal is having 3800 GCV, calorific value. You see the gross calorific value is 3800 with the normal Indian coal. Then where we are using all the biomass is having a calorific value of 2500 average, by weighted average, we are having a 2500 GCV. Means there is a heating value in the biomass. So this is the ash and the different biomasses. This is the ash range and moisture range. It is there in the graph. Then we are replacing each and every category of biomass. How much tonnage we are replacing? It is there. For each mini chip dry dust, we are daily 14 tons we are replacing. Totally we are replacing with 72 tons of coal. We are replacing with only biomass. So annual impact, what is the impact of carbon print? By using of this, we are using 36,300 tons of biomass. Annually we are feeding into the boiler, which is replacing of 23,984, means it is almost 40 days of our consumption of coal. Means 1.5 months we are saving the coal, which is equivalent to annual of 58,502 tons of carbon we are reducing, emissions we are reducing. We are the responsible organization. We are committed to reduce the step-by-step carbon footprint. So each stream, how much generation, it is already given on the graph. Because of 36,000 of bio waste, we have given the different stages generation. Then, by nutshell, we are taking into the before biomass integration. Our coal and biomass is 67 and 33. After doing of this last 3.5 years, we are consistently using this material. We are replaced 33 become 45%. We have increased the biomass. Now currently we are using 55% of coal and 45% of fuel. Okay, biomass fuel. Then we have. Because of today, the price is very high. Because of last year, floods are in the north region, the floods are high. Because of rice millers, the rice availability is not there. But our boiler is APC boiler and CFPC boiler. We have a compatibility. We can go biomass up to 68% also. We can have a flexibility to increase the biomass percentage, which our boiler can be absorbed. Okay. When the coal is peak prices, then we have increased the biomass percentage up to 60, where the RSS prices are down. That's why, where seeing into the total cost of operation, total cost of ownership, we are doing right now 45% biomass is replaced. So finally, high moisture is there, then low GC will come, then ash loading, flagging, fouling, corrosion. Majorly problem is corrosion and erosion is the boiler problem. The tubes are failing because of the two reasons. One is corrosion and another erosion. For erosion already I told two systems we have in place because of sonic soot blowing. Another is we have in place sleeves mechanism where the bends are there. There we have put the sleeves, we are putting so that the bends, the damages protected. So these are the risk areas and mitigation plan and control mechanism. Then what is the overall conclusion? Challenges are there, generation of combustible residue during raw material preparation. Disposal needs environmental because this is the solid waste management that already session chairman has told. Solid waste management is a bigger concern for the paper industry because of we are generating the solid, but disposal is a bigger issue. Where that disposal, how to convert it into opportunity, this is the one way to have innovation to do. Because of we cannot directly use in the boiler, but we should have intermittent processes to screen it properly and maintain the parameters and feed into the boiler. So solution is develop integrated waste to fuel system, converts residue into alternative boiler fuel, and value created is 110 to 120 tons residue recovered. Replaced 73 tons of fossil fuel is replaced. Reduced by carbon emission 177 tons per day. Your carbon emission, CO2 emission is reduced, which is saving, not only saving, it is the environmental footprint also. 10 CR we are saving by the 330 calculations, basic calculation. Apart from the savings, we are protecting the environment, we will reduce the emissions. And plant overview 540, production bleach in 450, and raw material is 1.65, wood and 1.65 extra. Impact is reduces the fossil fuel dependency, that is an important one. Second is lower operational and disposal cost. We don't have any disposal problem because we are using internal circulation. And it has a sustainability footprint. Okay, these are the challenges. At last, I will tell you two important things. So there is a operational efficiency improvement because of what we need to do by the industry, by all our industry partners. First of all, you have to conduct the energy audits. Because of today, the energy consumption is a prima facie is very, very critical for every industry. Because of the IE3, IE4, IE5 motors are come, you have to replace with the efficient motors to reduce the energy. That is one way we have to improve the operational efficiency. Second is process optimization. Adopt combustible means digital, by using of digital technology, you have to optimize the combustion efficiency in the boiler. That is giving the efficiency of the boiler. Then lean manufacturing, we have to go by 6 Sigma, the process variation reduction. These are the initiatives we have taken for operational efficiency. Then technical upgrades, high pressure boilers is the one solution for more energy recovered from the recovery boiler. Means we have to increase the pressures. I think ITC is having one of the in India is a high pressure boiler. So we have to all other industries, because of small and medium scale industry, recycle industry, they don't have recovery processes. They have to adapt it certain new technologies. For cogeneration systems, digital monitoring, smart sensors are already in place. We have to use the smart sensors. We have to optimize the boiler efficiency. Apart from the policy front, then we have to create a carbon trading complex, CCTS. Then we have to green financing. Then we have to corporate scope 1, scope 2 transparency. We have to bring it to across the industry. Thank you. For short term, 2026 to 2030, we have to do energy audits, biomass reduction, and recycling paths we have to maintain. In 2030 to 2040, we have to widespread of cogeneration, natural gas utilization, and digital optimization is the 2040 is the target line. Then 2040 to 2070, next 30 years, we have to go by net zero. Net zero trajectory with the renewables, electrification of drying. These are the challenges and these are the next 40 years, the target lines.